everyone. My name is Mackenzie.
I'm Tom.
And I'm Katie.
And welcome to
The Couch Potato Lab,
the show where we bring the science to you in your own home. Now, today we're going to have such a good time. Some would even say a rocking good time. We're going to be learning all about rocks and the amazing things that we can find on our Earth. And I brought today two lovely scientists. So let's figure out who I brought today. Who do I have on my left?
Howdy, everybody. My name is Tom. My pronouns are he, him, and a fun fact about me is that I share a birthday with my dog. And this Monday, we both turned 6.
Very good, Tom. Very good. You look great for your age.
Thank you.
Yes. So, my name is Mackenzie. My pronouns are she, her. And a fun fact about myself is that when I was younger, I just wanted to have a job where I could write on a whiteboard. And look at me now. I even upgraded to this beautiful blackboard, and I'm so happy to be here. Now, who do I have on my right?
Hello, everybody. My name is Katie. My pronouns are she, her. And a fun fact about me today is that I, along with my obsession with sushi, am obsessed with coconut. I love putting coconut on many, many things, so you may even see some coconut later today in the show. We never know. All right, but before we get into the show, we just wanted to take a moment to recognize that this live stream and eyes is operating on Treaty 4 land, which is the traditional territory of the Nayahuac, Nakaway, Dakota, Nakota, and Lakota peoples, as well as the traditional homeland of the Métis-Michif Nation. We are honored to be sharing the land with these people, and we encourage you to also look at if you are on other numbered treaties or from unceded territory as well. So thank you for taking a moment to recognize that with us.
Thanks, Katie. Now, before we get started with the show, I think we just have a few things that we need to, sort out here on the set. Tom, what are you wearing and why?
What do you mean? We're talking all about the science of rock and roll, right? And me, being the fervent rock and roller that I am, came dressed for the job that I want. I'm ready to rock.
Oh, Tom. Man, I think you read the description wrong. We're learning about rocks, like rocks. We're not learning about rock and roll, Tom.
Well, your first mistake was assuming that I read anything about this episode. But you know what? Do you think rocks can be just as exciting as good old rock and roll?
You know what, Tom? I don't think that they can be just exciting. I know they can be just as exciting. And I am so glad that not only are you a rock star, but you're also a geologist. So we're going to be learning all about what this geology and geologist thing is. And luckily, you're going to be great for that too. But I have to say, can you go, dress for the part? The rock and roll thing is a little much.
Well, maybe one day we'll have an episode on rock and roll, and everybody's gonna look real foolish when they're not dressed up like a rock god like myself.
You know what, Tom? You're right. You know what? We'll give you a second. You'll get back into scientist mode, and in the meantime, let's go see what our other scientist, Katie, has to say.
All right, so as much as Tom looked amazing, we are going to be talking about a different type of rock today. The rocks that we see outside all the time in our backyards, playgrounds, lakes, whatever it is. We see rocks all around us in our daily lives. And that's why they're so important and so cool. And we are ready to jump on this episode here with you. So first of all, we have 3 different types of rocks. The first type of rock is called sedimentary rock. And these types of rocks are composed of different pieces of dirt, sand, smaller stones all together. So they essentially kind of clump together and they form one massive rock. And because these rocks are composed of little tiny pieces, they get really heavy. And they're usually found at the bottom of different bodies of water. So like oceans, for example. So that's sedimentary rock. We also have metamorphic rock. Now, these types of rocks are when these little tiny particles of sand and dirt and all those little pieces get smushed further together because of applied heat and pressure. And this heat and pressure usually comes from the Earth's crust. Our final type of rock is called igneous rock. And these types of rocks occur when lava from volcanoes usually harden and they become rocks. All right, so those are our three types of rocks. We have sedimentary, the little pieces together, metamorphic, formed by heat and pressure in the Earth's crust, and then we have igneous, which comes in all different forms, colors, shapes, and sizes that occur when molten lava molts together. All right, and the coolest thing about these three types of rocks is that all rocks you've seen have went through all of these stages. So a rock is not only sedimentary for its entire life, it goes through sedimentary, metamorphic, and igneous all the time. And it's actually a cycle that is completely interchanging. That is such a cool thing about rocks. What do you think, Mackenzie?
You know what, Katie? I think you did such a great job of explaining that. I'm pretty sure that I could try to illustrate this in a cycle. So I'm gonna try to draw this cycle on the board, and then Katie, you'll correct me or help me along the way if I need it, right?
You bet.
Okay. So I'm gonna go ahead and let's start with sediments. So sediments are our little particles of sand or like our little rocks and pebbles. So I'm just gonna have our little sediments right here. Now I'm not a great artist, not a great drawer, so I'm just going to write the words and then we'll demonstrate them a little later on in the show. Now, Katie was saying how these sediments form together to create sedimentary rock. So I'm going to put a little arrow here and we're going to have sedimentary rock. Now, Katie, can you just remind me, how do we get from sediments to sedimentary rock? What do we need here?
So, in order to get those together, they essentially need to be squished together with pressure.
Okay, so I'm going to say that they need like compacted. So I'm going to put compact.
Exactly.
Perfect. Glad we're on the same page there. Now, when we go from there, we said that we went to metamorphic rock. So that was with heat and pressure, right?
Yes, that's correct.
Okay, so here we're going to metamorphic rock. That's a big word. You think we could say that together while I'm writing it?
All right, ready, Tom? 1, 2, 3.
Metamorphic.
Got it. Okay, metamorphic rock. And Katie said that that is created through heat and pressure. So I'm just going to write that here so we don't forget. Heat and pressure. All right. Now, in metamorphic rock, you can still see the different separations. But what happens is if you heat it up a lot, it turns into magma. So I'm going to just have a little one. This is kind of similar to these sediments. So right here, we're going to have a little subcategory called magma. So when you heat it up, this is going to be melting. So we're heating it up. It's getting really, really hot. And then it's magma. But from magma, that would be like the really hard lava. But we're talking about rocks here when they're cooled down. So this, when it cools, that's when we get our igneous rock. And that's from cooling. Now, the really cool part here is that if an igneous rock, if it cools down and it heats back up on the way back, it can actually turn back to magma. So that's kind of reversible. It can go back and forth. Now, Katie also mentioned how these don't stay just constantly, like it doesn't end its cycle right at the igneous rock. What happens here is that each of these rock types can actually break down. Now, in yesterday's episode, we talked a little bit about erosion, and erosion has to do with weathering and different parts of matter breaking down. So what can happen at any point in these cycles is maybe there's like a storm or just different things happening on Earth. They can break down, and we call that erosion, and then it breaks back down into these sediments. And that is where our cycle comes from, because it can continue back, and all of these arrows end back at sediments. So we're going to label these yellow arrows as erosion. If you want to learn a little bit more about erosion and test that, you can go and watch yesterday's episode as well. Now, Tom, you understand a lot about this rock cycle, so maybe we should try to demonstrate it so we can understand how things work through this pattern and continue to little back and forth. Do you have something we could do to show that?
Absolutely, Kens. I have humankind's best friend with me, Candy, and we're going to be illustrating the rock cycle using Candy. So, of course, it is a cycle, so that means that there's no end, there's no beginning. But let's start with sediment, sedimentary rock. We know that sedimentary rock is composed of different rocks and sand and pebbles that all get compact together, especially on the bottom of the ocean floor. So, you know, some I don't want to say young sedimentary rocks because rocks are as old as time itself. You can almost see like discernible pieces, like the different parts of it that it used to be. So I think starbursts work really well, but you could also use any candy that you have on hand for this activity. What I'm going to do is I'm going to take, I'm not going to throw them. I'm going to take a handful and I'm going to sort of simulate that pressure that you get from the ocean floor or the vacuum of outer space. I'm just going to crush them up together and create a little sedimentary rock of my own. Here, as you can see, yeah. We'll just keep it down there and I'll just keep pressing it. Yeah.
So Tom, what you're doing right now, that would be taking it from that sediment in the cycle down to the sedimentary rock. So you're at the compact stage, is that right?
That is absolutely
right
correct.
There?
Yeah, I am compacting it right now into a nice sedimentary rock. Would you look at that? It's gorgeous. It's a beautiful sedimentary rock. And of course, if we just keep going down this cycle, what would happen if we applied heat and pressure to it? We might get a metamorphic rock. Do you have anything on?
Well, Tom, I understand this is a cycle. So how about you toss that one over here, and we'll try to put that same one down through the whole entire cycle. So what I'm going to do here, we're currently at the sedimentary rock. So I'm going to apply heat and pressure, and then hopefully we'll end up with a metamorphic rock. So I'm going to do this by holding it in my hand. So holding my it in between my hand, I'm going to add that body heat that I have, and I'm also going to squeeze it and apply that pressure. Now I'm just going to keep holding this in between my hand and squishing it together. And then I'm just going to take a minute and we'll look at what it looks like here. All right. It's looking pretty good.
Looks pretty metamorphosized to me.
All right. So here we have it. You can see that it is just one little circle. It's like I can't really separate the sediments anymore. You can still tell that it was made of different sediments, but they're more compacted together because there was so much heat and pressure. It's going to be pretty hard to take it apart. Like I couldn't pull the yellow off of, say, the orange very easily. It would be kind of mixed together. You can still tell the difference, but it's not perfect. So now I'm at the metamorphic rock. So Katie, I'm going to toss it to you and see if you can continue the cycle.
That'd be great. Okay, awesome. So no matter how much pressure Mackenzie pushes on our rock, it will never all be one color together yet. So we do have to go on to the next stage in our rock cycle. So I know that you have all been wondering, what does Katie have on her desk here? And I'm about to tell you. So we have a little beaker and a little hot plate. What we are going to do with our rock is we are actually going to throw it into our hot plate here, and we are just going to let that warm up a little bit. So when we do that, I came early to set up, and I actually created another rock. And believe it or not, this rock is created from the candy that we originally used. And I know it looks really funny because it's all one color. So how did those colors mix together? Well, after Mackenzie did the metamorphic stage, we're going into the igneous stage. So the first thing that happens is the sediments melt together. And they create magma. And this is what we are doing here in our demonstration. The rock is heating up, and you can even see that it is kind of boiling down already, and it's kind of getting hotter, and it's melting down. So after it does that, if the rock cools off, then it's going to form a solid igneous rock, which is exactly what happened here. I took this from out of the hot plate, and it hardened, and it's actually quite, I'm not sure if you can hear that, but it's quite hard. And so that is representing igneous rock.
Great. Now, Katie, we have it at the igneous rock stage, but it doesn't stop there. It continues in the cycle. So what is going to happen to this rock now over time?
That's a great question, Mackenzie. Okay, so if we need to get it back into sediments to turn it into sedimentary rock, it is pretty hard, but we can go ahead and rip off some of the pieces here. So you can see here that I have one piece ripped off, and I'm just going to go down and I'm going to continue to rip off these pieces. And you can see that these pieces kind of look like what we started with. So we're no longer at that solid rock stage, but we have a whole bunch of mini sediments that are going to be able to compact and squeeze together and form our sedimentary rock once again.
Yeah, now one thing I did notice there, Katie, is that they did break down into like similar size, and maybe that happens through different weathering or wind, rain, whatever that may be. But the one thing I did notice is that it didn't necessarily go back to the exact color. I remember Tom started with some yellow, red, orange starbursts, and it all seems to be that like orangey, yellowy color all together. So just because it's in a cycle, it doesn't mean it's going to look the exact same in those sediments. So that's constantly changing throughout its life, but it's always going to go through those 3 different rock types, which is really cool, and it really makes me appreciate all the unique rocks that I've seen in my life, because I have no idea how they started or how they're going to end up. It's just always a mystery to me. I'm
That's
never
exactly
gonna know.
it.
Rocks
Yep,
are a mystery.
that's right, Mackenzie.
All right, so I mean, we've talked about the different types. We've talked about the cycle, but I think I'm ready to dive into some real rocks.
Real
Do you
rocks.
think we could do that, scientists? Did you bring anything?
Did we ever? If there's one thing that we always bring is real rocks. Now, this is just from a garden, but you could also get your rocks and sand from a playground. You can get them from someone else's garden with their permission. Rocks and soil is everywhere. But what you're wanting really is a bag about this size, and you're gonna need a pretty diverse collection. As you can see, it's mostly soil, but there's also some pretty big. This looks like some of that redstone that you see on landscaped yards. Very nice, very cool. I think that's a nice diverse amount of rocks. Because remember, sediment is also diverse, and then when it gets compacted into the sedimentary rock, it can still look quite what do you want to call that? Heterogeneous, right? Where you could still see the different parts. I think we talked about heterogeneous mixtures a couple episodes back.
Yeah.
So, what you're gonna need is some soil and rocks, just a nice bouquet of dirt, a plastic cup, and some glue. Yeah.
Now, speaking of different things, different materials, looking different, I understand from what I see here, I think that Katie has a lot different type of material. Katie, what are you doing over there? Are you still doing the same thing as Tom?
Well, guys, Tom was prepared, and he went out before the show and he collected the dirt from his garden. And I woke up late this morning in a hurry, and I didn't have time to do that. So I thought instead what we could do is build an edible rock. Okay, so if you want to follow along with this edible rock, we are going to be using a Rice Krispies cereal. So I already pre-made mine here. I was prepared for that. Of course, I'm always prepared for the food aspects. So I have 2 layers of my Rice Krispie mix already prepared. And then what you're going to need are some different toppings, some different candies, nothing specific, but whatever you want to use, whatever you want to snack on would be fantastic to make your edible sedimentary rock.
All right, and I think that's great. I'm really glad that we have such different materials, because I think that it doesn't even matter if you had the same materials and I would have the exact same materials, our rocks would look really different, and that's okay because all rocks are different in nature too. So we're going to be creating a sedimentary rock. Tom's going to create a sedimentary rock. Katie's going to have one. The only difference is that Katie's going to have a snack at the end of this, and Tom's not going to have a snack. So I hope he brought his own, but that's a problem for later. So I think we should just dive in here and create our rocks. What do you think, scientists?
Absolutely. And let me just say, you were 100% right, Kens. What I will be making is not a snack, so please do not even try to eat it. You will get a mouthful of dirt and glue, and let me tell you from experience, it ain't a winning combination. Let's just get started.
Let's get started. All right. So maybe what we'll do is we'll go through the different layers and I'll show you on my mega edible rock here. And then we can also follow along with Tom as he creates the real sedimentary rock. Okay, so the first thing we are going to do is we are going to grab our first layer of our Rice Krispie mix. So you should have a layer maybe about 1/2 inch thick, whatever you want. You can always ask your parents for help if you need help with creating the Rice Krispie mix. You can heat it in the microwave or on the stove. And we're going to take our first layer here, and this is going to represent our first layer of our sedimentary rock. So we had mentioned how rocks are very, very, very old on the earth. But of course, the rocks, as Mackenzie said, are constantly changing and they are always adding layers to the rocks. So this is going to be our first layer. And what we are going to do is we are going to add another layer on top of our rock. But rocks don't always look the same. They have different colors, sometimes different textures throughout them. So I don't want to put another layer of our Rice Krispie mix right away. So what we're going to do is we are going to take our first type of candy. Remember, you can use whatever you want. If you've looked at past episodes, specifically Graphing is Great, you know that I am a hardcore chocolate chip fan. So I made this beautiful little mix of dark chocolate, milk chocolate, and white chocolate chips. And what we're going to do is we are just going to go ahead and pour our candy on top of our rock. And then we are going to just kind of spread it out throughout. You want to make sure that you cover a lot of ground throughout the rock, or if you want, you can kind of just put it in one section because again, all rocks are unique, all rocks are different, composed of different layers and different materials throughout. So as I'm spreading this over here, let's go take a look at what Tom's doing with the real sedimentary rock.
All right. So nothing quite as delicious, but just as important. So what I'm going to do is, because it is a bunch of loose sand and rocks, I'm going to create a very small base using just some glue in my cup. Make sure you have a clear cup so you can see your progress. Just going to add some glue there. A nice dollop, as they say in the food industry.
So you're using white glue, Tom, but you can use kind of any type of liquid glue, is that right?
Yes, any sort of binding agent will work. Clear glue, a glue gun. Tape would not be good at all, so don't try to use tape. And then what I'm going to do is I'm just going to, I'm not going to discriminate what falls into the cup. I'm just going to let it all fall pretty freely. Maybe I'll get some big chunks, some little chunks. And again, Katie was talking about how the distribution of chocolate chips, we can kind of think of those as deposits. Now, when you think of a deposit, you think of something that your parents do at the bank, but no, a deposit is a sort of area within a rock or a mountain kind of thing that has a specific mineral, and we're going to talk about minerals in just a little bit. So, what I'm trying to say is, it doesn't have to be perfectly uniform, and it certainly doesn't have to be perfect because all rocks are imperfect.
Yeah, Tom, in yours there that you're making, I love that you can see like that sand, soil, dirt mixture, and then you can also see the different rock sediments, so you can really tell the difference. Kind of similar in Katie's, how you can see the Rice Krispie layer, and then you can also see the different types of chocolate chips, and those all represent the different sediments, so we can tell that it's made up of a bunch of little different pieces. So I love that, Tom, yours is made up of those tiny little particles, and they're all together.
Yeah.
All right, so as Tom is continuing adding his next layer, we are going to take a look back at our edible rock. You can see here that I have my chocolate chips spread all throughout our layers, and as Mackenzie was saying, they all look a little bit different. Okay, so because this is also going to be my tasty treat, I want to add another layer of Rice Krispie mix. So what I'm going to do, I have my layer pre-cut. I'm just going to go ahead and smash that kind of right on top of there. And if I turn it, here we go. You can see that I have my first layer here I have my second layer here. You can kind of see some of the chocolate chips peeking out from under that layer. And then we have our Rice Krispie mix. Now, this is super interesting because when you look at a real rock, sometimes you can see the different layers just by turning it on its side. And you know that whatever layer is the bottom layer is going to be the oldest layer in our rock. So in our edible rock, the oldest layer is the bottom Rice Krispie mix. The next oldest one is the chocolate chips. And the newest one is actually our top Rice Krispie mix.
Great. Yeah, that's similar to how we built it. So it's kind of like the reverse. Now, Tom, yours, I don't know, is yours ready yet? Or do you have to wait a while? I don't know. It doesn't look very hard yet.
You know, that's a great question. Like all rocks, it will take a while, probably not the thousands and millions of years that most rocks take before the shape that they are today. This one will take maybe about overnight, just let the glue settle in. As you can see here, it's quite loose. So if you just want to bind it at the top with a bit more glue, just to make sure that when you pull it out, you don't have a big cup full of sand, that would work great too. So I'm just going to add a little bit of glue just to be the glue that holds it all together.
Right. Now, Tom, you have another rock there that you created before because I know how much you love rocks. You're a geologist after all. You have rocks everywhere in your house. It's like every decoration ever for you.
It's true.
Take a look at it.
Yeah, so this was a rock that I made a couple days ago actually, and just as you can see, it's quite hard. It's quite, it looks like a cookie.
Wait. I thought you weren't making a snack, Tom. To me, that looks like a snack. Do you want to take a bite of it just to make sure, or?
You know what? No, I will not.
You're that sure it's definitely a rock, right?
I am that sure it's definitely a rock, but you know what? The best way to store this rock is to keep it in a nice, cool place. I know that we have like lights and cameras here in the studio, and it's actually starting to melt the rock. So just make sure that, especially on a day like today when it's 30 degrees outside, that you don't leave it outside. Because again, a mess of glue and dirt really makes your backyard hurt, is what I say.
Right. Now, scientists, from what I understand, I kind of personally, I know I'm learning, but I think you might be missing a step because we went from sediments to make a sedimentary rock, but I think you need that compactness. So, I don't know. What do you think, viewers? Do you think they have to like compact it down? I think you have to.
Definitely, Mackenzie. Yes, you are for sure coming on to the rock crew with Tom and I. You are definitely rocking and rolling up way here, and we are going to finish off our rock exactly by doing that. So if you have another type of candy or topping that you want to add to your edible rock, then you can go ahead now and add that. My fun fact for today was that I love coconut, which is very much true. I am obsessed with coconut, and so I brought some coconut here, and I'm going to go ahead and just add this as our final layer. Okay, so now we have our complete rock, which has 4 different layers. 2 Rice Krispie layers, 1 chocolate chip layer, and 1 coconut layer. So here we go, we have our edible rock, and if we want to make it a metamorphic rock, we are going to do exactly what Mackenzie did with the candies before. We are essentially just going to kind of pat it down, compress it together, and we're going to squeeze it together, and it's going to, I can even feel it right now, it's definitely squishing down, and it's very much sticking together. I would definitely have a hard time taking this one apart. So I would say that at this stage, my rock is a metamorphic rock.
You know, Katie, I might even challenge you to take it one step further if you want. We know that metamorphic rock has heat and it has pressure. So I'm thinking about the heat here. I'm thinking about the pressure, the heat from your hands. What if you like tried rolling it up like one of those rolls? Would that apply more pressure to the inside chocolate and maybe the coconut as well to get
You know what? That is a great idea, Tom, and I think that we should give it a try right now.
Give it a try.
If you are following along at home, you can also give this a try and let us know if it's working out for you. Let's see if it's going to work out for me. I'm going to get my
here we go.
Hands nice and warm here. Try to get that heat.
You got that friction going.
Exactly. Got that friction going. We're going to try to make more of an igneous rock. Okay.
Hey, it's doing pretty good.
It's doing pretty good.
Wow, we got some coconut all over the place. Well,
Just like real
Well,
rocks.
you know what? That could be like the erosion happening. Some of it's going to break off over time.
Mhm.
exactly.
Yeah.
You know what, viewers? That was wonderful. And it looks like to me here that we have one pretty nice igneous rock.
Very good. Oh, there it is, the erosion.
It's like a giant candy burrito, but I know it's a rock.
All
great.
right. Now, we can see that there's different sediments in that, but I don't know. Is that the only thing that rocks are made of? Or is there something else in there too? What do you think, scientists?
Well, we hinted at it before, but rocks have things called minerals. Minerals are these natural substances made by the earth, sorry. They contain things like calcium, carbon, nitrogen, other metals like iron. Katie, what else do we find?
Yeah, exactly. So these minerals, two of the ones that I always remember are diamonds and gold. So all these types of minerals actually make up rocks. So if you believe it or not, there are little tiny particles that make up the rocks, kind of like atoms make us up.
Mm-hmm.
All right.
Yeah.
So we actually have another question here about minerals. And the Hayes brothers, they want to know, they say, we know that rocks have minerals, but how many minerals does the average rock have? And that is an amazing question. So scientists, can you answer that? Because the Hayes brothers want to know, but so do I. I can't wait to figure this out.
Yeah. Well, you know, every rock is like a snowflake. There's no two that are exactly alike. However, there are some very common minerals that do exist in the majority of rocks, such as calcite. I could think of one. What's the other one, Katie? Off the
It's-
top of your brain.
So limestone is made up of calcite and aragonite. So those two main minerals, but again, like Tom said, it all kind of varies. Other rocks may have very trace amounts of many different types of minerals.
Mm-hmm.
I want to learn a little bit more about these rocks. From what I understand, these rocks can be tested for different physical properties. And physical properties are things that we can observe and test so we can learn more about the rock or substance itself. Now, luckily, these scientists are amazing geologists. And geologists, that's what they're doing. They're testing different rocks and different substances on Earth so we can learn more about them and understand what they're made of, what their different capabilities are. And I'm pretty sure as they were setting up on set, they brought all their materials in. I'm pretty sure they brought a bunch of rocks. Is that right?
That's correct, Mackenzie. Of course we did. We always carry the rocks in our pockets.
It's true.
So do you think that we could do a couple different tests for these different physical properties, you know, using some of the materials you brought, and so we can figure out kind of what each of these rocks is special for and like what their properties are?
Yeah, absolutely. So we have some very cool rocks, as you can see right here. I'll just bring them up here. And, you know, back in my day, we didn't classify rocks by such physical properties. You know, I would have called this one green rock, white rock, and a blackish gray rock. But luckily for us, we got a lot smarter, and now we can begin testing the physical properties, like you said. And one of them, actually, if I may start the testing, is the acid test. And this tests for effervescence. So what I have here is some 5% hydrochloric acid. I'm sure we're all familiar with hydrochloric acid. It's a very strong acid. At high concentrations, it can burn your skin. So if you somehow manage to get your hands on it, please use gloves and with a parent. But also you can use common household vinegar as well. This will work great. And what we're looking for is a reaction to the acid being applied. So should I just drop it on all three and see what happens?
Go ahead.
No, Tom. I want to do it one at a time. I need to make notes. Got it?
All right.
Okay. One at a time.
Well, I guess it's important that we stay organized.
You're right.
It's true. Yes.
That's why I have
Okay,
Ken's
how about
and
we
Katie here.
how about you do one, I'll write it down so I don't forget, and then we'll do the next one. Is that
Yeah.
a good deal?
Absolutely.
Okay.
All right. So I'm just going to place a drop. Just one drop is all you're going to need. And maybe the camera can't pick that up, so I'll place one a little bit further up here so they could see it. And I'm not sure if folks at home you could see it, but it's actually fizzing quite a bit. I'm scared to use more because this is hydrochloric acid. Let's see if you could pick that up there. Oh, it's going on the table. That is A-okay. But it does fizz. So a more scientific term is it's effervescent, which
Great.
is just fancy for fizz.
Now, Tom, which rock was that again? Can you remind me? I made this beautiful chart here. I just want to make sure I'm putting the right information in the right spot.
You know, I jumped the gun. We we should actually name our rocks besides the colors that they are. This green rock right here, this is fluorite.
Okay, I'll put that note here just so I remember.
Yeah, fluorite. This white one is calcite,
Got it.
and this black one is magnetite.
Amazing.
Mhm.
All right, so then the white one that we just tested was effervescent, so
Mhm.
I can just put yes. It's a simple yes or no. Is that right?
Yes.
Okay, so I'm going to put yes.
All right.
All right, next, I'm ready.
All right. I'm just gonna put a drop on good old fluorite, and nothing's happening. Absolutely nothing is happening.
All right, so that's a big, huge NO.
NO.
All right.
All right. Finally, we're gonna apply it to our magnetite. Absolutely nothing happens.
All right, so we got another no.
Mm-hmm.
All right, so next thing I have here is fluorescent. So, Katie, can you teach us a little bit more about what it means to be fluorescent?
Yes, I definitely can. Okay, so fluorescence, like effervescence, is another type of physical property. And remember, that is what we are testing with this experiment, different physical properties. So Tom and I, as geologists, will test these different physical properties so that we are better able to identify different rocks. So, say for example, I didn't know that these were the different types of rocks that Tom just said. One test that I might do is the fluorescence test to try and identify what the different types of rocks are. Now, fluorescence, I'm going to be using this fancy flashlight here. And what we are going to do is we are going to shine in on each of the 3 different rocks, and we are going to see if the rocks reflect that light back to us. So we're essentially trying to see if that rock absorbs the light, if it bounces back off, and we are able to use this test to determine if the rock is fluorescent and again identify the rocks based on their physical properties and the minerals inside of them. Okay, so I'm going to start with the calcite rock, and I'm going to just shine the light directly on the calcite here. And you can see that it's not really reflecting back at me. It's just shining on the rock, and it is not coming and bouncing back off. It is not kind of glowing in the dark is what we're looking for. It's not glowing in the dark, so that is a no, Mackenzie, for our calcite.
All right, I'll add that here. We got a no for calcite fluorescence.
So
Perfect.
now let's check our fluorite to see. So when I shine the light on our fluorite rock, you can see that this actually does have that glow in the dark feature. So it looks like if I was to go and turn on my night light for the night. So it does have that glowing feature. That light is bouncing back off at me, and you can see that yes, fluorite is fluorescent.
Perfect. So I'll add that here. That's a big yes for fluorite's fluorescence. All right, one more.
Awesome. So now with the magnetite, let's go ahead and see if this is fluorescent. And you can see that no, it is not fluorescent. It looks very much like our calcite. It is not reflecting that light back off.
All right, so I'm going to add a quick no here. All right, looks like the next thing we're testing for is hardness.
Mhm.
Tom, can you teach us a little bit more about the property of hardness, please?
I absolutely can. So, as we know, many rocks are quite hard, they're quite dense, but some rocks are harder than others. Some are quite easy to break apart and flake. And so what we use in a hardness test are several materials, starting with things that might scratch it, that might break the rock. So I'll start with my fingernail. And I'm trying not to get where the acid is. I'm going to start on fluorite. And I'm just going to see. And it doesn't seem to be scratching whatever, you know. So I'm going to say no, but also I can move up and use something harder like a knife, right? So I'm
Okay.
going to try For those viewers at home that don't like the sound of metal on rocks, this might be time to plug your ears.
What about the penny, Tom? Could you try using the penny? I'm intrigued.
Absolutely. So yeah, I kind of went from one extreme to the other. It didn't scratch the knife. Nope. It didn't scratch the knife. But let's just try. Oh, that's the knife on the. Yeah. Here we go. Real time. No, it doesn't seem to scratch the penny at all. So you saw that. So I'm gonna give it a big no. For fluorite. That's the wrong one. But you know what?
Oh, whoopsie.
I'm going to try the penny on the calcite now. But you know what? I'm also, it's not going to work on there. We're going to rub it up against the knife. Nothing.
Now, Tom, if I feel like we're getting a lot of yes or no questions, but I kind of want to rank them. Like, I understand that, like, yes or no, but I feel like you can't just say no for hardness. So what if we tried to, like, put it on a scale of 1 to 10? It wasn't very hard. So what if I gave it, like, a 3? Would that be fair?
Absolutely. That'd be a fair number.
I think a better observation here to test this physical property would be to put it on a scale. So we're going to test them from 1 to 10. So we're going to change this to a 3 for hardness.
And you know
and
what,
then we'll have
Mackenzie?
something to gauge them on back and forth.
Yeah, I went ahead and I did the fluorite test before the show, and I concluded that it was a 4 on the hardness test.
Oh, so we're pretty close. So maybe I'll add a 3 to a 4 because we were saying before that all rocks are unique. So maybe there's maybe a little bit of a tiny bit of a range between the two. So we'll give it a 3 to a 4. Amazing. All right.
And finally, we're going to use the penny on the magnetite. Honestly, it's I'm gonna try the knife now. Oh yeah,
Whoa,
it is.
yeah.
Oh yeah, listen to that sound. Like awful music to my ears. So it scratches the knife, but it doesn't scratch the penny, which is really interesting. So what would you put that on the scale?
Honestly, I think that if it's scratching a knife, it must be pretty hard. So I would give it like, I don't know, like an 8, 8.5, 9.
Yeah, I feel comfortable with 8. Absolutely.
Okay, 8. So I'll give it an 8. Amazing. You're the geologist, so I trust what you think.
Yeah.
And you know, when I was kind of observing, I thought the calcite was pretty much the lowest ranked. Do you guys agree?
I would agree. Absolutely, Katie.
Yeah, so should I put the calcite? We had fluorite at 3 to 4, so maybe I'll put calcite at a 2?
2?
2?
Yeah.
Sure.
Why not?
Put it at a 2.
It's the weekend.
All right. So we got our hardness. Now we want a couple other things to test to put them apart because you can kind of see that like these two are kind of similar. They only had the changes here. So let's move on to streak color and see if we find anything else that's a little bit different there. Katie, do you want to lead us through this one?
Yes, of course. All right, so next physical property we are going to be testing, like Mackenzie said, is the streak color. We are going to be using this little white cement block here, and what we are looking for are the different colors of the streaks that the 3 types of minerals leave. So let's go ahead and test our calcite off first. So I'm going to go ahead and just scratch the calcite down. And again, the cameras, there's a little bit of a glare, but it actually left a big white streak down my cement block. So go ahead, Mackenzie, and you can write white for streak color for calcite.
All right, we got white.
And the coolest thing is that you can even see that you could predict that calcite would leave a white streak because calcite is a lighter block. So let's go ahead and test the fluorite. Will it leave a white streak, a green streak? I don't really know. Let's go ahead and test it out.
Whoa.
All right, so we can see that just like the calcite, the fluorite also left a white streak. We have no changes on our cement block, so I'm going to go ahead and say that fluorite left a white streak.
All right, sounds good. And we have one more left, the magnetite. Let's test the magnetite on the streak plate.
Okay, here we go.
Oh, wow.
Whoa. All right. I think I can go ahead. I think I can conclude that this is a black streak. Am I right, Katie?
You are very right, Mackenzie.
Great. All right, now just to finish up my chart here, Tom, we have a physical property of magnetism. So can you go ahead and test our rocks for that so we can finish this off?
Absolutely. Magnetism is how magnetic it is, so how much magnetic ore might be in this rock. So things like iron, aluminum, things that are magnetic that might be deposited in this rock. So I'm going to go really quick, starting with calcite right here in the middle. I have a magnet here, and we're just going to see if it sticks.
Looks like a big no for me.
Huge no.
All
Biggest
right.
no in the land.
Great.
We're going to move on to fluorite. And it's
Another
not doing
no.
anything.
All right, big no for that one as well.
And then our good friend magnetite.
Can I predict?
Absolutely.
I'm going to say yes just because it's called magnetite. Let's test it out.
They wouldn't call it not magnetite. Oh, would you look at that?
Whoa.
Oh, yeah.
Okay.
Look at that. So it's very magnetic.
So that's a yes.
Very tight.
So the thing about these properties is that they're not just there for fun. We don't do them just to kind of describe them. Geologists use these properties because certain rocks have them. So if they have two rocks that look pretty similar, they're going to use these properties to try to distinguish between the two of them. So let's say they had a calcite and a fluorite that looked pretty similar. They weren't sure if it was the two of them. They could do the acid test, and if it was acidic and if it reacted, they would know it's calcite. If it didn't react, then they would know it's fluorite. The similar for the fluorescent. If they didn't know, they could put the light on it. If it was fluorescent, out of even these three rocks, they would right away know it's fluorite. So just to make sure that I got these properties in my head, I think we should do a science showdown and test them. What do you think?
Let's give it a
Sure,
try.
yeah.
All right, so here's what we're going to do, scientists. I'm going to not only test what I know for properties, what I just learned, but I'm also going to test to see how quickly the two of you, as geologists, can identify the rock I am talking about. Now, before I do this, I just want to invite all of our viewers to text us in your questions because we have a really exciting, my favorite segment of the day coming up. So text your questions in at 306-570-1013, and also reach out to us on social media. We have @EyesYouth is our handle. You can find us on Facebook, Twitter, Instagram, YouTube, and TikTok. And just make sure you're using that hashtag CouchPotatoLab, and we'll be able to find your questions there. Now, I'm going to call this segment for Science Showdown Eyes Spy because I am going to have one of these rocks in my mind. I'm going to be looking at it. I'm going to use these properties that we just used to try to describe it, and then you're each going to get a guess at which one I'm looking at, okay?
Sounds good.
Okay. All right. Here we go. I spy with my little eye something that is leaves a white mark. It reminds me of something a dentist would use because it's actually found sometimes in mouthwash, this mineral. Whenever you get the idea of what it is, just buzz in, let me know.
Buzz.
You buzzed it. All right, Tom,
cool.
what's your guess?
I'm going to guess fluorite.
Okay, well, I think it's only fair if we let Katie have a guess. What do you think, Katie?
Well, I don't know where Tom got that from. I think it's calcite.
Well, Katie, I hate to break it to you, but Tom was right. And that's actually right. The mineral in here that's found in fluorite is actually in our fluoride for our mouthwash or toothpaste and things like that. So dentists use it a lot, which is really, really interesting. All right, so I'm going to put that down. I'm going to get another one in my brain here. All right, I got it. I spy with my little eye something that would stick to this blackboard. Keep in mind that the blackboard
Ding, ding,
has
ding.
these. Yep, Katie, what is it?
Okay, I want to redeem myself. So I think it's magnetite.
Okay, Tom, any guesses?
I just love fluorite so much. I'm going to say fluorite again, just because it's the best.
Well, Tom, I think that your nerves are showing through because clearly I'm talking about magnetite.
Ah,
Magnetite is, in fact, magnetic.
come on.
So we got a point and a point. So let's do one more so that I can do a tiebreaker. Are you ready for this? This
So
one might
ready.
stump ya.
Born ready.
I really think this one might stump ya. All right, I spy with my little eye something that is salty. Might taste like salt. It's found in our food. It's not something we've talked about today, but it's a rock that I know you're studying a lot. Katie, I'm pretty sure. Is your hand up?
Yep, my hand's
Okay.
up. It was a little bit of hesitation. You know what? I know that calcium. No, I don't think it's calcium. I think
Oh,
it's.
she's backing down.
I'm just gonna go ahead and say salt. I don't.
Salt.
Yeah.
Okay, Tom.
You know, if it tastes salty, if it looks salty, if it's salt, I'm going to go ahead and say that it's sodium chloride.
You know, the two of you, you're so smart. I'm surprised you didn't know this. But luckily, I researched a lot of things before this episode, and it's actually halite. So
Oh.
it's halite. It tastes like salt. And Katie, I'm going to actually give you the half a point because you were the closest. It is found in our table salt, so it's practically salt. So the point goes to Katie. Katie wins the science showdown for today.
That's wonderful. Tom and I have always had a geology feud, so I'm very happy to have finally won, and with many viewers to witness that.
And this only makes our rivalry more intense and more cutthroat than ever.
All right. Now, I just want to remind you can text in those questions, and we'll get to those in just a minute. Now, the one thing I think is really, really interesting about rocks is that we use these rocks every day and we don't even realize it. And actually, there's different cultures in Canada that use these rocks for a lot of different reasons. Now, the Inuit peoples, they actually use these for navigation. So I have a graphic here, and what I'm talking about is an Inukshuk. And these Inukshuks are built up. They're used for navigation, so maybe there's a really good hunting spot or a different trail, and they build these rock structures as a way to tell other people where they are, where they're going, where they've been, and it kind of acts as a landmark so that they know where they're going. So one really cool thing about Inukshuks is that they're very sacred, and if you see one, you're not allowed to knock it down because they're going to use it for a lot of different generations. So lots of people rely on them to get around and use them as navigation. So that's one really cool thing that
cool.
the Inuit people use rocks for in their everyday lives. Now, Katie, what other things can rocks and minerals affect our everyday life in?
Awesome. Okay, so again, they're in our everyday lives, and they're actually also present in our bodies. So if you ever heard of calcium, which is what I almost guessed on the last Science Showdown question, calcium is super important for our bones specifically and our muscles. But we're going to take a look at how important calcium is for our bones. So here's our graphic here, and we have a term called osteoporosis, which is a condition in which the bone fragments become weak, and you can see the healthy bone is full of different calcium and different bone fragments, whereas the osteoporosis one is very porous. It has a lot of holes in it, and that means that our bones will become very weak. So I have a little demonstration here to show everybody. So I have a bone that is meant to represent a healthy bone. So you can see I have 4 toothpicks all together, held together by elastic bands. If I go ahead and try to break this, it is not going to break. And this is what a healthy bone looks like because it is full of calcium, which is super, super important for our bones to stay nice and strong. Whereas I'm going to take a single toothpick here, and this is going to be representing our bone that has osteoporosis. And so maybe it's not getting enough calcium and it's becoming more porous. It has holes in it. So if I go ahead and try to break it, it's going to easily break. So that is exactly kind of what is happening with minerals, specifically calcium in our bodies.
Great. Now, I know that we have a lot of burning questions that people are just dying to get answered, so we're going to head into our favorite segment of the day, and that is Ask a Scientist. Great. Now, we have a lot of questions to get to today, so we're just going to start from the top and then get on going down. So we have a question here from Eli, and Eli wants to know, what is limestone? What are gemstones? Now, Katie, you mentioned limestone in your live today when we were showing people what was happening behind the scenes as we were getting ready. And Katie, can you answer this? What is limestone?
Definitely I can. So thanks for your question, Eli. So limestone is composed mainly of calcium carbonate, and it may be found specifically from seawater precipitation. So it is a type of rock that you would find out on the earth, whereas gemstones is a name given when a jeweler goes ahead and cuts a stone, polishes it up, and it may be used for necklaces or rings or bracelets. So even though the names sound kind of similar, they are very different. Limestone is of course found naturally on the earth, and gemstones, as they are rocks, they are cut and polished to make different things.
Wow, now I know exactly where all my jewelry came from. Now we have another question here from Hannah, and Hannah wants to know, is coconut a nut? Now what do we think, scientists?
You know what? It's kind of cool. Coconut is both a nut and a fruit. So it's kind of like a special case scenario. Even though it doesn't look like a fruit, it actually is. But it only has one seed, and it has the typical 3 layers that a fruit has. Now, I know that this was maybe our 3rd episode back at banana DNA extraction, but every every berry has 3 layers: an exocarp, mesocarp, and endocarp. I might have gotten those completely backwards, but they do have them. So they're a fruit, they're a nut, and they're 100% delicious. I hope that answers your question, Hannah. Thanks.
Well, now Katie is definitely going to know what she's eating when she eats her coconut on the daily.
Exactly.
Okay, so we have another question here, and Eli actually has a suggestion, and they say try a transparency test. Now, if I were to try a transparency test, like, how would I do this? Geologists, can you help me out? What is this?
Yeah, so transparency means how much light can shine through something. So to do a transparency test, Eli, we would take maybe a flashlight. Let's see if I have one behind me. No such luck. But see, I have a UV flashlight right here, which doesn't really do the same thing because it has UV light instead of actual light. But we could for sure do one. All you need is a rock and a flashlight, and if the rock passes through it, then yes, it is transparent, but if it doesn't, then it is opaque. Am I using that term correctly, opaque?
Yeah.
I never went to art school. Hopefully that answers your question.
Perfect. Thank you, Tom. Now we have one last question that we are going to get to, and Theo wants to know, why do we have to eat minerals to be healthy?
Okay, so that is a great question, Theo. It kind of goes back to what I was saying before. So I know that my parents always told me to eat my vitamins, be nice and strong, and that is exactly what minerals do as well. So as we eat our minerals, they're going to help us grow, develop, and stay strong throughout our lives. So minerals have a lot of many important functions in our bodies, from helping to grow bones like calcium, others help the heart muscle pump, others help to build hormones. So just like vitamins, it helps to keep our body ticking the way it should.
And if I may add on to that, Katie, the reason why we get them from our diet is because our body actually can't make it itself. So things like, maybe blood is something that our body makes for us, but things like calcium and other stuff, that needs to come from our diet in order for us to live.
Yeah. Great, Tom. Thanks.
Great. Thank you for answering that question, scientists. Now, I hope you had a rockin' good time today. I know I learned so much, and I think that's it for today. Hey, scientists?
Yeah.
That was a rockin' great episode.
That was. So hopefully we'll see you tomorrow, and we're going to learn more about science. So we'll see you there. Bye.
Bye.